So I wanted to make a follow-up video about solving equations with variables on both sides. We talked about this in class, and I don't know if everyone got the recording or if it worked for each class. So I'm going to go ahead and go over the basic steps to begin with, and then I will do 2 examples that we didn't get to in any of the classes today for you guys, just for some extra practice. So we're going to start with the steps for solving equations with variables on both sides. So what are these steps? Step 1, and I gave these in class, is to distribute if necessary. So if there are parentheses, we are going to distribute those parentheses and make sure that we take care of them. So this is essentially step P in our little checklist. This is our little P, okay? Our second step is to clear fractions. Again, this is if necessary. And this is basically step F. All right, so it's the same steps we've been talking about for almost 2 weeks now. Now we're just looking at them in a sense of how are we using them all together. So step 3 is combine like terms on the same side. So this is L. We're going to combine those like terms on the same side. And then step 4 is the big one. Step 4 is our super new step. And that is going to be to move all variables to the same side. So this is the step that we haven't done before. We've been doing this for almost 2 weeks, like I said, and V has never come up until we got to this type of problem, okay? Our next step is to check to undo all addition or subtraction, and there should only be addition or subtraction. It shouldn't be both. So this is A and S. And then lastly, we're going to do undo multiplication or division. I will say this, if you clear fractions, you're really never going to have division to undo, okay? So that's M and D. So if you clear the fractions, you're really never going to have multiplication, or you're never going to have division to undo. You usually do have multiplication at the end. So these are steps we're going to use. We're going to go through them. We're going to make sure we understand them, and make sure that we go through and we know how to solve these equations with this extra new step. If you've already been doing a great job in solving them with just the first steps, then this shouldn't be too much harder to add in a new step. So I did examples 1 and 2 in class. So I'm going to work on examples 3 and 4 right now. If you need to copy these steps for whatever reason, please pause the video and do so. I'm going to go ahead and clear them and go ahead and scroll down to questions 3 and 4. So we're going to look at examples 3 and 4 just to make sure everyone knows how to do these harder ones. So the first thing we're going to do is we're going to draw our line to separate our sides. Y'all, I'm such a stickler about that because it makes life so much easier. And I'm actually going to use the line tool so I can have a straight line. So we're going to go through and we're going to follow our steps for please forgive lovely Violet, although she missed dinner. So I see parentheses. So we're going to take care of the parentheses first. So 6 times 1 is 6. And we got to make sure we distribute to both things. 6 times 3K is 18K. So I took care of the parentheses. I'm just going to bring down what's on this other side, okay? I luckily do not see any fractions. And I also do not see any like terms on the same side. If we check this out, I've got negative 18 and negative 6K. Those are not alike. And I have 6 and 18K. Those are also not alike. Remember, to be alike, they have to have the same variables with the same exponents. I do have variables on both sides. If we check this out, you guys will see I've got a negative 6K and a positive 18K. And you know my rule, we always move the smaller variable. So my smaller variable here is negative 6K. So I'm going to add 6K to both sides. I'm going to move that one by doing the inverse operation. And because I did the inverse operation, these two will cancel, which means I'm just bringing down negative 18 in this side equals 6 plus 24k. 6 plus 24k. So then I check and say, okay, I do have addition to undo. I do have addition to undo, but I am not undoing the plus 24k. I want to leave that here because I always want to leave the variable where it's at. I want to undo this positive 6. I want to undo this positive 6. So it's a positive 6. To undo that, I do the inverse operation. I do minus 6 on both sides. These are going to cancel. And now I have to look over here. I have negative 18 and a negative 6. So we're adding these together. So we add them together and we keep the sign because they both are negative. So we add together, keep the sign. So we have negative 24 equals 24k. There's no subtraction undo, but there is multiplication. So to undo multiplying by 24, I'm going to divide by 24 on each side. These cancel, and I get k equals negative 1. Because negative 24 divided by positive 24, we're dividing a negative and a positive is a negative. I get negative 1. So it means negative 1 makes the equation true. So I'm going to check this one for you guys and show you what I mean by it makes the equation true. So here's my equation, negative 18 minus 6k equals 6 times 1 plus 3k. So what I'm going to do is I'm going to take my eraser and I'm going to erase my k's, and instead I'm going to plug in what I got for k, which was negative 1. So I'm going to do 6 times negative 1 and 3 times negative 1. Okay? So now when I start to solve this, I have negative 18, and then negative 6 times negative 1 is a positive 6. So negative and a negative is a positive 6. This equals negative 18 plus positive 6 is negative 12. So this side is negative 12. Let's see if the other side becomes negative 12. So 6 times 1 plus 3 times negative 1 is negative 3. So I get 6 times 1 plus negative 3 is negative 2. 6 times negative 2 is negative 12. So look, both sides ended up being negative 12. That is what I mean when I say negative 1 makes the equation true. I can take negative 1, I can plug it in for the variable, and now both sides are going to be equal. That is what we mean every time we say it makes it true. That's the solution. All right. So now we're going to try this next one. We're going to try this one. This one's a little bit bigger, but I think we can do it. So we're going to use our little checklist. So we see parentheses, so we're going to start with parentheses. So we're going to distribute 2 to 4x, which is 8x, and 2 to negative 3, which is negative 6. We are not distributing 2 to negative 8 because negative 8 is not inside the parentheses, okay? So it's not inside the parentheses, so we're just going to bring that negative 8 down. And this equals 4 plus 2x. So I go back to my checklist. I took care of parentheses. I do not have fractions, but I do have like terms on the same side. I have negative 6 and negative 8 that are alike. So we're going to add those together. What is negative 6 plus negative 8? Well, if I add these together, I'm going to get negative 14. So I add them together, keep the sign. So I have 8x minus 14 equals 4 plus 2x. All right, I do have variables on both sides. I have an 8x and a 2x. We're going to move the smaller one. So to move a positive 2x, I'm going to subtract it from both sides. Those cancel. I get 6x minus 14 equals 4. I don't have any addition to undo, but I do have subtraction to undo. So I have a minus 14, so I'm going to add 14 to each side. I get 6x equals 18. We have multiplication undo, so we're going to undo timesing by 6x by dividing by 6. And we get x equals 3. x equals 3 is our answer. So 3 makes the equation true. So that means I can plug 3 back in for x, and it's going to make both sides equal. I think both sides are going to equal 10 if I do that. And you guys can check it if you want to. Okay?